Hi everyone! We still know surprisingly little about the ocean, mainly because underwater data is so hard to collect. The underwater vehicles like the AUV and the UUV, they usually use side-scan sonar to scan the seafloor, producing waterfall-like images from the echoes. But these images often come out noisy, distorted, and filtered with water columns. Cleaning them up can take hours, which means it's far too slow for real-time use. So I developed a four-step onboard pipeline that turns raw sonar images into clean, accurate maps instantly. First, we clean both the acoustic and navigation data. The sliding window filter suppresses spike noise, and the Kalman filter smooths the vehicle's motion using position, velocity, and orientation data. And this gives us a solid foundation before imaging. And based on those clean data, we can form the raw waterfall image. But we need to handle the water column in the center of each waterfall image. That blank region actually shows how high the tallfish is above the seafloor. To solve it, I trained a lightweight UNet model to segment each frame. But since one side of the image can be distorted by noise, I added a symmetrical wheel mechanism to keep left and right boundaries aligned. And even under harsh conditions, the model can achieve over 98% accuracy. And then we also need to correct the brightness, because sound faded with distance, so the closer area will look brighter. Then we apply a time-varying gain to balance the image, making features easier to see. And finally, we fix the geometry. Since side-scan sonar uses slant range imaging, it scans at a fixed angle, so features don't appear where they really are. By modeling the triangle between the tallfish, the echo path, and the seafloor, we can map every pixel back to its true location. We tested this whole pipeline in China Wuzong River and also in Bohai Sea using standard onboard hardware. It worked reliably in real-time mission and provided image quality comparable with the offline method. Thanks for listening, and this is all about my proposed method.